Product of sine and cosine integral function. So we have done a lot of videos on sine integral function, cosine integral function separately. Now this video will include both of them in their product, so it's gonna be kind of cool video. But though the problem is cool, solution will not be cool because I will be citing one of my previous solutions, so you may not like that, but yeah, that's what I'm gonna do. So integral from 0 to infinity, and we have SI of Q of x. Let me write the definition of both of them. So SI of x is basically negative of the integral from x to infinity of sine t by t dt, and Ci of x is basically negative of the integral from x to infinity of cos t by t dt. Yeah, those two were the things. Okay, now this is integral from x to infinity, also negative sign over here, and then cos of t by t dt. Now if you want to make these limits numbers, you can basically make a substitution that y equals to t by x. You can make the substitution, and this makes the integral from 0 to infinity Si of qx. The integral is from 1 to infinity now, and then cos of t is xy by t is also xy, and dt is xdy. And there's a dx over here that I've forgotten. Dx over here. Yeah, now the x cancels out. Yeah, we can also interchange the integrals. So we can basically take the constant inside and interchange the integrals. Integral from 1 to infinity, integral from 0 to infinity, Si of qx cos of xy by y, and then dx dy. Now the cool thing in this is 1 by y is just a constant, and thus 1 by y can be taken outside over here. Yeah, and now this, for this integral, this is kind of same as integral from 0 to infinity Si of qx and cos of ax dx, and we have already solved this integral in the previous video. Yeah, and the solution was minus 1 by 2a ln of a plus q by a minus q. Yeah, and I will link the video over here and in the comment section as well. Yes. Okay, now using this result, we can say that this integral over here is just 1 by y, and then minus 1 by 2 times, in place of a here is y ln of a plus y by a minus y. Yes, and dy. Okay, cool. Now minus minus cancels out, and we can take 1 by 2 outside. We get integral from 1 to infinity 1 by y square. Yeah, and then ln of a plus y minus ln of a minus y. Yes, and dy. Now let us try to use partial fractions. I mean integration by parts. Yeah, and that gives us, first of all, let's write it as it is, ln of a plus y by a minus y. Yeah, and the integral of this thing is minus 1 by y minus integral from 1 to infinity. Now its derivative is 1 by a plus y minus 1 by a plus y minus y. Yeah, now again the derivative of minus y is minus 1, so that makes it plus over here. Is that it? 1 by a plus y plus 1 by minus y. Yeah, I guess this is it. and then we have 1 by y minus 1 by y as well. Yes, it's integral. And then dy. Now this is from 1 to infinity, so we have 1 by 2. At infinity, this is just ln of 1, so that's 0. Yeah, and over here it's minus sign, so that becomes plus, and y is 1, so we basically have ln of a plus 1 by a minus 1. Is it? Yes. And then negative sign, and we have integral from 1 to infinity, minus minus becomes plus, so 1 by y times a plus y plus 1 by y times a minus y dy. Yes. Now the next thing to do would be 1 by 2 ln of a plus 1 by a minus 1. Over here, if we have to break this to partial fractions, it will just be 1 by y minus 1 by a plus y. Yes, and we will have 1 by a over here, and similarly over here also it will be 1 by a minus y minus 1 by y. Yes, is that it? Y minus a plus I think it's not. I think it should be plus. If it's plus, y plus a minus y, and y cancel out, work here. Here also 1 by a is common. Yeah, and then dy. So we basically get, what we get is basically 1 by 2 ln of a plus 1 by a minus 1. Yeah, and then plus 1 by a, integral from 1 to infinity. Here, so we have 2 by y plus 1. Okay, so 2 by y. Okay, this one is also minus 1 by y minus a. Other one is also minus 1 by y plus a. Yeah, and dy. Okay, so now we are close to solution. 1 by 2 ln of a plus 1 by a minus 1 plus 1 by a. Now this is 2 ln of y minus ln of y minus a minus ln of y plus a, that is ln of y square minus a square. Yes. Now this is pretty close to the solution. Yeah, and 2 times ln of y minus ln of y minus a square. Okay, now next thing would be, okay, what would be our next thing? Now so this first term is already evaluated from 1 to infinity, but we haven't really evaluated this thing, so we have to make sure to do that, to evaluate this thing from 1 to infinity. Yes, so we have 1 by 2 ln of a plus 1 by a minus 1 plus 1 by a. This is just ln of y square by y square minus a square from 1 to infinity. Yes, so we have 1 by 2 ln of a plus 1 by a minus 1 plus 1 by a. At infinity, this is ln of 1, which is 0, minus ln of at 1, this is 1 by 1 minus a square. Yes, so we have 1 by 2 ln of a plus 1 by a minus 1 plus, now reciprocating this we get minus sign, so minus minus becomes plus, 1 by a ln of 1 minus a square. Yeah, now is there anything else that we can do for this? Is there anything else that we can do? Let's see what is basically the answer. Let me check the answer and then try to see if we are going correct or not. Let me try to see if we are doing it correct or not. So over here, we basically have this thing itself, but here's a slight difference in what I see over here. Oh, the difference. Why could have the difference been created? No, I don't really think that will matter. Let me check the answer actually. The answer is okay, 1 by 4. This is A or Q? It's over here. This is actually Q, but I have replaced that with A. Is that? Okay, wait a second. Yeah, this is actually Q. What you see as A is actually Q. Yeah, and this is Y. We're doing it correctly now. Okay, so in a formula, it should be A plus Q. That should be Y plus A and Y minus A. Yes. Oh, and that was the okay. So if you make it Y plus A and then Y minus A, I guess at last you are getting over here A square minus 1. I think that was the main problem. Isn't that? Yeah, we will basically get A square minus 1, not 1 minus A square. And this is not A, this is also Q. So basically get Q square minus 1. I'm sorry for that mistake. And Q plus 1 by Q minus 1. Yeah. And next thing, are there any more errors? Okay, now I think there aren't any more errors. That was it. And now we know that this is just 1 by 2 ln of, and so okay, here also with the same error it could be 1 plus Q by 1 minus Q over here, but it doesn't really matter in log. Yeah, whatever order it is, because we are giving modulus sign. And then also 1 by 2Q ln of Q square minus 1. Now since there can be ambiguity in the sign, what we can do is basically make it 1 by 4, then square the inside. 1 plus Q by 1 minus Q square. You can do it like this just to avoid the ambiguity. And then over here also we can do same thing, 1 by 4 and then ln of 1 plus Q by 1 minus Q square. So this solves the problem. This is clearly the answer that's in my answer copy, and this has been verified. So yeah, this was the solution. The flow was just to change it to use definition, and then we used the previous result and use integration by parts, partial fractions. That was it. So hope you enjoyed the video. Thanks for watching and look forward to seeing you in the upcoming videos too.